Welcome to Spring LIB.
In question 34, we have two linear waves, and we represent them by d1 equals f1 xt and d2 equals f2 xt, and both satisfy the basic definition of equation. That is, dx over dx squared equals 1 over v squared of derivative of second derivative over t. So if both d1 and d2 satisfy this equation, we want to show that any construction d equals c1 d1 plus c2 d2 also satisfies this equation. So in order to solve this problem, all we need to do is to plug everything inside. So over dx squared is the derivative of the derivative. So this, since derivative is linear, derivative of d with respect to x equals c times derivative of dy with respect to x plus c2 times derivative of d2 with respect to x. And then when we take the second derivative, because c1 and c2 are constants, we can just take the derivative of these two. So that gives us c1, the second derivative of d1, plus c2, the second derivative of v2. And we can do the same to the second thing. Over v squared, and we have d dt over dx dt, which is equal to c1 derivative of dy with respect to t plus c2 derivative of d2 with respect to t. And again, because c1 and c2 are constants, we can take the derivative of d1 d2. So they become second derivatives. Okay, now what we have, we look at these. Since both d1 and d2 satisfy this equation, then we have d1 over dx squared will equal to 1 over v squared of the second derivative of d1 with respect to t. So this term will be equal to this term. And of course, I multiply both of them by c1, but they will still be equal. And similarly, this term will be equal to this term. Remember, there is a 1 over v squared outside of parentheses. But these two terms will be equal because d2 also satisfies this equation. And of course, I multiply both of them by c2, but that does not change the equality. So this whole expression is equal to the second derivative of d with respect to x. So that is to say, d also satisfies this relationship if both of its components satisfy the relationship.